Okay, so we've established that F is a homomorphism. We've established that F is surjective. Now we need to establish that F is one-to-one. I think that word is injective. I always get those words the wrong way around. So that means that F is an isomorphism. So we've done that, we haven't done that yet. These three together give that. Okay, so how do we do that? Well, what we mean is that if f of n x1 equals f of n x2, then for it to be for f to be one-to-one, this has to imply f of nx1 equals f of nx2. That has to imply that nx1 equals nx2. Okay? Well, let's just assume this and see where we go to. If f of nx1 equals f of nx2, that means that phi of x1 equals phi of x2. You'll remember that phi maps G to H was our original homomorphism. So that tells me that phi of x1, phi of x2 to the minus 1 equals the identity, because I'm just bringing this over to the left hand side. And that tells me that phi of x1 x2 to the minus 1 is the identity. And that tells me that x1 x2 to the minus 1 is a member of n. Remember that n equals the kernel of phi, which is the set of elements which are mapped to the identity. And look, they map to the identity. There it is, look. So what does that tell me? That tells me that x1 is related to x2. They're in the same coset. And that tells me that nx1 equals nx2. QED. What we've done is we've gone from this statement here that the f of x1 equals f of x2, sorry, f of nx1 equals f of nx2, and we've deduced that nx1 is the same set as nx2. Alright, so there's the last piece in our jigsaw. So let me just state the whole thing. If phi is a homomorphism which maps G to H, if n equals the kernel of phi, which is the set of elements in G that are mapped to the identity, then G over n is isomorphic to the image of phi. And this is the first isomorphism theorem. Isomorphism. Depending on how you count them, there's 3 or 4 of these guys here. But there it is. G over ker phi, G over n, which was the kernel of phi, was isomorphic to the image of phi. There it is. I think that's absolutely fantastic, and I'm going to stop there.